Then, from those old processes of the Carnot cycle I just described, how can you draw those processes of the Carnot cycle on the TS diagram and also on the PV diagram? At this moment, I really want you to make a pause of this video lecture and try to make your own sketch of TS diagram and PV diagram by yourself. Then I'm during that time that I'm going to move to the whiteboard to explain more about how we can sketch TS and PV diagram. While you try to do your own sketch, I draw TS diagram here. Okay, then I made a KHTL S1 and S2. Now, how can we draw the TS diagram of the Carnot cycle? Now, how can you draw the first process 1 to 2, which is reversible heat input and reversible expansion process? Now, during the entire heat input process, I already said that there should be isothermal process. So no matter what, heat transfer should be in the, should maintain the same temperature all the way. Now, we can draw 1 to 2 here. Okay. So obviously, because heat is transferred in, entropy should be increased because of entropy transfer from surroundings to your system. And now, when the first process 1 to 2 is done, then we have isentropic expansion process that should be going here. Okay, so that is 2 to 3. During this entire process 2 to 3, we have to maintain the same entropy. Okay, then from 3 to 4, we have heat rejection process. Now 4. Okay, again, that's isothermal process, means that your temperature should be maintained during this heat rejection process. And also at the same time, there must be certain reversible compression process as well. And now we have isentropic compression process, which is reversible the compression process. Now that is all to 1. Now, from 1 to 2, we have heat input. So let's say the Q in. And from 3 to 4, we have rejection of heat. Okay. Now, how can we calculate QH or Q in and Q out? Okay. So now Q in and Q out. So in order to calculate this Q in and Q out, which are reversible, okay, then those Q reversible in and out can be calculated by the second law of thermodynamics. Okay, then how can you write the second law of thermodynamics? Now let me write it down. So small change of your entropy in your system is due to the entropy transfer due to heat transfer and small entropy generation. Now, if Q is reversible, then we don't have entropy generation. Now, so reversible amount of heat can be written as T D S. Then how can you draw write Q in a Carnot cycle? So Q in can be written as T H, okay, because we have constant temperature, and T S2 minus S1. The amount, the heat rejection can be written out as TL and S2 minus S1. So now we have those two equations for Q in and Q out. Okay. Now how can we express that equation of Q in a TS diagram? What do you think? In that case, graphically speaking, this equation gives us entire area under the process 1 to 2 is the amount of heat input. Compared to that, heat rejection, the amount of heat rejection is underneath the curve from 3 to 4. So now, this is the amount of heat rejection in this counter cycle. Okay. Then from the first law of thermodynamics we discussed in the last lecture, if we apply the first law of thermodynamics for cycle, what we can relate between the heat and work is work net out should be same as Q in minus Q out. Okay. So if you go back to this TS diagram, now Q in is this amount of area, and Q out is that much of amount of area. So now the subtraction of these two gives us the area of net work out. In this case, your area is only this part. So the area of the closed loop of your cycle always gives you W net out. Okay. Then, in terms of equation, by putting those equations into the W net out, then it gives us TH minus TL times S2 minus S1. So now that is, again, basically the equation of rectangular area of your TS diagram. Remember those two equations for Q in and Q out, and also this work net out.